Hello, today we're going to have a quick look at the equation of a normal when we've got an equation where the base is not e. Okay, so we're going to find this equation line and then we will actually look at the second example there, which is using the product rule in a couple of examples. Okay, so here, for example 1.12, we have the equation y equals 2 to the minus x. Now here, to derive this, I'm actually going to use the rule that, well, if I had y is equal to a to the function of x, okay, so to derive this, I'm going to have the derivative of the power, so f dash of x there, and I'll multiply this by the original function, and then I'm actually going to multiply by log to the base e multiplied by whatever the constant base there is. Okay, so to derive, use this rule with the example given. So dy dx here, deriving the power up here is -1, so multiplying that by the original function there, which is 2 to the minus x, and then I'm going to multiply that by ln2. Okay, brilliant. So that's our first derivative. Now, for the normal, okay, so, or the gradient of the tangent. So if the gradient of the tangent was if I was to sub in x equals 0 in this case. So if I go m of tangent, so here I'll have -1 minus 1 times 2 to the minus 0 times ln2. So this would be -1 times 1 times ln2. Okay, now the gradient of the tangent multiplied the gradient of the normal must equal -1. So subbing that in here, so I'll go -ln2 times gradient of the normal is equal to -1. So therefore, the gradient of the normal will be positive ln2. Okay, brilliant. Now let's put this into our 1 point and gradient formula, which I'm just rewriting here. However, I actually don't have a y value, so I should sub in the x equals 0 into the original function, which when I do that, I'll get just an answer of 1. So the point will be 0, 1. So I go y minus 1 is equal to the gradient, which we said was ln2, multiplied by x, and our x coordinate was 0. So therefore, I'm going to get the equation of the normal as ln2, or x ln2 plus 1. Brilliant. Okay, so let's have a look at example 1.13 and use the same rules but with the product rule. So for question A here, I'm going to set it out as I usually do. U will be the first function here, which is 3 to the x. Deriving this, now I'm going to use the rule that I've got in the box here. Okay, derive the power, it comes down the front. Deriving x, that becomes 1, multiplied by the original function, multiplied by ln, and then the integer base. V here is x, so the derivative of x we know is 1. Okay, so using the product rule, okay, so I'll multiply those together, so I'll get uv dash, so that'll be 3 to the x times 1 plus vu dash, so here I'll have x bracket 3 to the x ln 3. Okay, now here I can actually see that I'm going to have a common factor of 3 to the x, so let's take that out. Brilliant. Okay, and that's our solution there for that first one, A. All right, for question B here, now you don't actually need the product rule because 4 is a constant. It's not actually a function. It's a constant multiplier, so you can just derive the 3 to the x and then multiply it by 4. So here I'll have the first derivative of 4 multiplied by, now I'm going to derive the 3 to the x, so deriving the power, which is 1, multiplied by the original function. I'm using that rule that we have up here in the box, multiplied by ln, so log base e, and then the integer base there. So just to clean this up, so I'll have 4 ln 3 multiplied by 3 to the x. Brilliant. So that's those two examples there.